Okay, so let's take a look at Unit 9. Unit 9 here is a nice, brief, fairly easy, small unit where we go back in time and we revisit cubics and cubed roots in terms of what we've learned about polynomials. So 9.1, our first step here, is just graphing cubics. So I'm going to give the graph of our basic one. So our basic parent graph is y equals x cubed. Nice, straightforward, but it has a fairly unique shape. You'll find as you graph the cubics, they tend to be fairly tall and narrow. So let's take a look at some points. So cubics will pass right through origin as our starting. So we have an x-intercept of 0, 0. We have a y-intercept of 0, 0. We just plug in 0, we get that. If we plug in a 1, we get 1. If we plug in a negative 1, we get negative 1. Now, first bit of warning, when you graph these, do not connect it straight through. That is incorrect, and I do take points for it. You need to graph them accurately, actually plot the points. If I plug in a 2, we're already all the way up at 8. 1, 2, 3, 4, 5, 6, 7, 8. If I plug in a negative 2, we're all the way down at negative 8. So our basic shape here is kind of similar to the parabola on the right, but going up even faster. So if I start sketching it here, we get something looking kind of like this. Now, one thing to note is that the graph completely levels out for just a moment right there. It actually goes flat, and then it starts coming out, kind of like when we did our square roots. Notice that it is not a straight connecting line between parts anywhere. It's always curving. It's still changing as it goes. This is our basic parent graph, y equals x cubed. If we take a look at this, our domain, it goes left forever, it goes right forever. Our range, it goes down forever, it goes up forever. So both our domains and range are all real numbers. X-intercept is right there at 0, 0. Y-intercept is right there at 0, 0. So this forms our parent graph. Because the shape is interesting, because we don't have these linear parts, you must graph them accurately. I do take a lot of points if you're just drawing straight lines, if you're not getting the curvatures right, if you're evening things out. So you have to actually plot points and make sure it is actually correct. Now, that being said, all of our usual rules apply. If we have something on the inside, like y equals x minus 2 cubed, that becomes a right shift or a horizontal shift of 2 units. So all of the rules that we've talked about all this year for graphing still apply. If I add something at the end, x cubed plus 1, that would be a 1 unit vertical shift. If we made it negative x cubed, all right, that would end up flipping it. Negative x cubed, if I were just to sketch it, would end up looking something like that when we go through and try to graph it. So what your goal is with the homework is just to carefully graph them out and see how they change. This is more exploratory in nature. I'm just giving you warnings as what you need to do as you graph them and double check that everything is actually working. Now, in addition to these, we do have something else. Cubics can double back on themselves. So it's possible for us to graph cubics that end up doing things like this. Now, these little points down here are known as extrema, or relative local maximums and minimums. So relative, or sometimes people will call them local, maximums or minimums. Basically, it's any time that we have like a little hill or a little valley. So this point right here is actually taller than all the stuff immediately around it. So this is a relative max. This point is lower than everything immediately around it. So this is a relative min. So on the homework, I'll ask you to find relative maxes and mins, but we're just doing it graphically. So use your graphing calculator, use your Desmos or online graphing tool, whatever you're going to use. I will say it's not enough just to eyeball it. You need to actually use the utilities to find them. So if you're using a graphing calculator after you graph it, you can usually find maximums and minimums From the graph, it's often under the calculate menu. You'll find maximums or minimums, and then it's going to usually give you some prompts. It'll ask for a left or a lower bound, depending on what model calculator you're going. And what this is doing is it's asking you where it should look. So when it asks for a left lower bound, say we're trying to find that minimum, I'd physically move the cursor a little bit to the left, and then I'd hit enter. Then it'll ask you for a right or an upper bound. So we go to the right, and then some models will ask you to guess. And that's where you just put the cursor as close to where you think it is, and then it will tell you the coordinate point of the minimum or maximum. That's basically it. This is a super short little lesson. It's mostly just graphing and utilizing all the skills that you've done before.